Good evening. This is another office hours session. This one's for the MP buffers class. Tonight we're going to be talking about .set files and using buffers in a .set file to configure output for a setup sheet. So we've got a pretty simple part file set up here. Let me make sure we've at least got a tool change or two so that we'll be able to see that. All right. Now we got some tool changes. So first I'm going to set up this file to use a .set file. By default, I'm pretty sure we use let's see,
I think it's
setup sheet again.
tool paths.
Tool paths, that is.
Tool
Okay.
paths.
Yeah, that's right. So we're going to go from active reports to .set file. And then to set the actual name of the .set file that you're going to use, that would be up in files. So if we go to mill setup sheet template, this is where you can actually assign which .set file gets run in the system. You can also, I believe, choose which .set file you want to associate with a machine. Or maybe it's with the control file. I'd have to go check. I think it might be the control file. But that way, when you pull in that machine, you could have a custom set file per machine if you wanted. A more advanced user would probably want to do that. This is just going to be the default, right? So mill.set. If we go and look in the browse here, and it doesn't have the setup sheet filter. Okay, so but if we go down, make sure it's sorted by type. We've got mill.set and mill2.set. So those are the two default set files that come with Mastercam. I'll just choose mill.set here. So now when we right click and do setup sheet, it will run that mill.set file. So let's go ahead and look at that .set file. So we'll browse to shared MCAMX7, mill posts. We happen to be working in mill this time. And we're going to choose mill.set. And I'm going to choose to associate it with the Mastercam X editor. You could also use Code Expert. CNC software, has two different editors available now. Code Expert being the newer one. I like the Mastercam X editor because I think it opens faster, especially when you're doing iterative work. I just like that a little better. So, as a .set file, it's just a post file. So if we go in and we look, there's a bunch of switches that are at the top that you can set based on your preferences. What are your output settings? Do you want to output comments from the operation? So output operation comments in the tool list. Do you want to output the new X comments, machine name, group comment, group name? So you can choose whether or not you want to output these. In order to output these options here, machine name, group comment, group name, believe we also have to enable that. So output comments to NC file. Here we have output operation comments, output machine name, output group name, output group comments. So if these aren't on, it doesn't matter if you turn that switch on in the set file or not. These all have to be on to get that info. So now if you were to repost. Oh, sorry. We don't want to post it. We want to right click and do setup sheet. Let's see what kind of errors we're getting. So, looks like doing that created an error. That's interesting. So, it tells us that we're running shared mkmx7 mil post mil.set file. So, post version info, update post version 16 was used to modify. Oh, that's interesting.
Post product mil.
So, it looks like... Oh, here's part of it. I ran it on a 5-axis part. So the logic that's in that file is set to only work with a 4-axis post processor by default. So if you wanted to use a .set file, we would either, we could add logic to calculate the rotary values and output them, that type of stuff. But we would also have to go in there and take out the logic that's looking for this right here, only single axis rotation. In order to do that, okay, as we go through here, more setup information. We can come back to that in a minute. So let's look at this this 4-axis error. Scroll back up to the top. Okay, and what I'm looking for is the predefined variables that control the way that MP processes code itself. So the first one that we're looking for, the most important, is rotax type. So if I do a search, ROTAXTYP, I believe. Let's just search for, oh, there is no rotax. Okay. So, if you start typing a variable name, and you do Control Spacebar on the keyboard, that will give you a list of all of the predefined variables in Mastercam. And if you start typing part of a variable, it'll help filter through that list. ROTAXTYP. So that's the variable that we'd be looking for. And if it's not set, then we can make some assumptions. So I'm going to go down and scroll past all of the setup info, all of the string select tables, the formatting here. And we're going to go down to where we actually start calculating values. So that should be PSOF, P header, just like a normal post. And see down here, P tool change, PEOF, P setup. And so what we're going to be looking for is where that error message comes out. So, what are you looking to capture in the .set file?
Well, what I've done, what I've been doing with it is I've edited it so I don't get quite as much information by default. You know, it puts a lot of information there. I just have it kind of pared down to bare bones information there, and then I'll save it as I'll open it in Word, and then because I like to have a lot of times I'll have a picture at the top of the file to to show the operator where the origin is and any additional notes. So I take a screenshot of the Mastercam screen and then input that into, basically paste it into the top of the file and then print it out from there. I was just wondering if there's a way to, you mentioned something about Excel, if there's a way to synchronize the .set file with Excel, because eventually it'd be kind of nice to maybe even have a company logo or something that I can incorporate in. And then, like I say, pictures are always good because if there's a language barrier between me and the setup guy, picture's worth 1,000 words. So
Sure.
that's how I try to work my setup sheets, that anybody, no matter what language they speak, can kind of get an idea of where the origin is and how to hold the part and stuff like that. You know what I'm
Sure.
probably trying to get at. And like you say, it does seem like there's some work to be involved with setting that up.
Yeah. Let's look in this. So here's what we can do in this class. In this class, we can look at how do we format the data and get it out from the buffer so that we can capture anything we want, right? And and then we'll look at some basics as far as importing data into Excel. Like, I don't want to get too far off into the VBA weeds where we try to, set up the stuff in Excel, but we can certainly look at how to get the data out, which is, I think the most important part of it, because then you can also use other skills, to get that information and do whatever you want with it.
Yeah.
Okay. So the first thing that I see is that there's no real setup info in the .set file that tells it what it can be used for. So what I would be looking for is, like, in the P setup. Here we got P prep and all that stuff. I did notice that there was a P setup here, and I didn't see anything here about rotary axis. So what that's going to do is that's going to default the behavior in MP to only process 4-axis rotation. So I think this could be as simple as just doing this. Adding rotax type and setting it to a setting that supports 5-axis output. And I believe that's anything like greater than 2. Let me just verify that real quick in the documentation. Okay. So the place we're going is volume 2 of the MP reference guide, and we're looking at rotary processing. And the most important variable is going to be rotax type. So rotary axis type. Right. So it's a post switch variable that most heavily influences the rotary output. The rotax type switch provides selections for either one rotary axis or for 5-axis motion, 2 rotary axes. Most post customization files are also developed along these lines and use 2 different techniques to produce output. So these settings, -3, -2, -1, 0, and 1 are all single axis rotation. So we're either going to want to use 2, 3, 4, or anything greater than 6. So a lot of the times you set it to a big number like 9999. This allows rotary support in the post customization file by calls to specific post blocks, but then the post writer is responsible for all rotary calculations. The nice thing here is that we can simply assign this, what do we got, C9K? That's our constant value up above here, right? Defined as 9999. So we'll just set that there, and now when we run this again in Mastercam, I'll right click, setup sheet. By setting the value of that variable, let me close those out again, so then that way we can make sure that we're we're generating it fresh. But that should be all we need to do to disable that error. So now again, if I right click, setup sheet, we got mil.set, no error.
No error. Good.
Okay. So if you ever want to run mil.set with a 5-axis post set rotax type $sign to a value greater than 2, really you want to set it to 9999, or whatever, anything greater than 2 will shut off that error. Now let's look at what's already buffered first. So if we go down in this post, there are 2 buffers already. These are all the parameters that we're grabbing. Buffer 1 definition for max min XYZ storage. Okay, so this buffer stores the XYZ extents of the file. RC1, read counter 1, WC1, write pointer, write counter. Okay, we got a note from Derek. He says he fixed video 1 and we should be okay now. So once we get done tonight, you can go ahead and check that out.
Okay.
Cool. Oh, sent that to everybody, not just him. That's okay. Okay. All right. And then we've got a variable size 1 that we're going to use whenever we want to read the buffer size to tell us how many records we have in the buffer. Then we have an implied array. 1, 2, 3, 4, 5, 6, 7, 8. 8 variables. And in our buffer definition, it's right here. fbuff 1, that's the buffer number. Remember this from class the other day? What's the second one here? We'll have to go. Let's go look it up, because I always forget whether it's the initialize flag or the keep flag. It's one of the two. So how buffer files work. There we go.
Oh yeah, it's the keep or keep.
So keep flag set to 1 to keep, or 0 to discard.
Yeah.
So one of the things that we can always do is turn on that keep flag, so that when we're done running the buffer, we get the data that the buffer accumulated written out at the end. This is an 8 numeric variable buffer. Okay, we can tell it's numeric because we've added that 5th parameter on the end that says, is it text or is it numeric? 0 being numeric, 1 being string. So that means every time we write a row to our buffer file, we write all 8 variables to that row. And that means if any one of these variables is not set, it just gets a 0 value written to the row. And that's what we call a record. So each row is called a record. In other words, we're writing all 8 of these variable values at once whenever we do the writing.
Routines. Oh.
So now we've got some various post blocks that get called for our buffering at different stages. Here, p init initialize the limit checking variables. We start out and we set each one of these values, max underscore x position, and you notice it says m underscore c9k. So that's going to be minus 9999. Min x position c9k, which is going to be positive 9999. Same thing here and here. So x, y, or y, x, x, y, y, z, z. We're setting the extents of variables that are used for checking limits. So in this case, our limits are, in English, minus 9,999 inches, positive 9,999 inches. So we're using these at some point to do some checking. So there's p init. Here's p limits, so check for new xyz limits. And we're going to see if we look for both of these. Let's see where these are called from. I'm going to set a bookmark for p init, and then I'm going to search for p init. And we've got an instance, oops, let me undo that. We've got an instance here in p read buff 1t. So it says read buffer 1 at the tool changes for XYZ limits. And if I search again, here it is, p read buff 1e, read buffer 1 at the end of program for XYZ limits. And if I hit it again, there's the definition. So it's only called twice. It's called when we start the buffer read routine, which is going to be at every tool change. So that's start a file and every other tool change that occurs. And then we're going to call it only at the start of p read buff 1e, which is, read buffer 1 at the end of the program. So that's where p init gets called. P limits, you'll notice here that what we do is we call p init. Then we get the next set of buffer values. So we're reading here with RC1, and it says B1 G code equals RBuff, so read from the buffer. We want to read from buffer number 1, and we're using RC1 as our variable that tells us which record number to read. So somewhere this has been set for us. It's either set because it's the initial, or it's the very initial time we're using it or something. We can look at that in a second. So what this does is this reads all 8 of those values. So right here, when we read from the buffer, we are grabbing all 8 variables and we are loading them into here, 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 and here. So these 8 variables will now be set from this one line of code. That is like the most confusing thing to figure out about buffers. Once you understand that every time you read and or write from the buffer, you are reading or writing a set number of values, and that the number of values that you are reading or writing is always the same, and it's always the exact number of values that you have defined for your buffer. So if you define a buffer with 30 numbers in it, you have to have 30 variables available in an implied array. And you tell it, okay, this is the first variable in my list. Now go grab all the variables that are on a single line, which is a record. So read a record from the buffer, and load all of those values on that one line into a list of variables starting with this variable. So now we've set these 8 values, and then we call p limits. So P limits gets called, and now in P limits it says if B1 underscore X max is greater than max X position, max X position equals B1 max. So we're checking each of these X min, X max, X min, Y max, Y min, Z max, Z min against these other variables that we initialize to a very low value. So we start out with these very, very low, very improbable values to make sure that the first time that we run this, it loads in the first set of correct min-max values. And then what happens is, since we have set these values to our buffer values, these values persist. Every time we run P limits again, the X min max, the Y max min, the Z max min gets checked against whatever the last set of values from the last toolpath were. And it only gets changed if it's greater. So by having these multiple toolpaths with different sets of X, Y values, as you run and accumulate and iterate through those tool changes, it will keep checking only against the absolute extents in positive and negative for X, Y, and Z, and it will just accumulate whatever the greatest movement is in X, Y, and Z. So, boom, 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 boom. P right buff 1. This is where we first start writing to the buffer. And you'll notice it says P right buff 1. And what are we doing right here? We're setting the variable values. Let me remove all my bookmarks and set a new bookmark here. We're setting all of the values for these variables in this list here. So you notice we've got B1G code, we've got B1T code, we've got B1X, max, X min, Y max, Y min, Z max, Z min. So the only thing this holds is the G code value and the tool code value, and then the X, Y, and Z extents of that tool. So when we go back and look at P right buff 1, first we set B1 G code. And it says B1 underscore G code equals G code $. G code $, is going to be dependent on where this is called from. And my hunch, if we go look at where P right buff 1 is called from, is that it's called from a tool change event. So if we call here, you notice it says PWRTT. So what this does is this captures values during the NCI pre-read event. PWRTT only gets called for certain codes in the NCI file. It gets called for the tool change codes. So that's going to be 1001. 1001 is the start of file. It's going to be 1000, 1000, and that's a null tool change event. And it's going to be called for 1002, which is an actual tool change. So here, at every tool change, we are writing buffer 1 and we are writing buffer 2. And that's the only place you're going to see that this gets called. So at every tool change, we capture the value of G code. And now it says if G code equals 1002 and op ID equals previous op ID, B1 G code equals 1.
That's a null tool change.
So what we're saying is if it shows up as a tool change, but the op ID has not changed, then we're going to tell it it's actually a 1000. And now it says if G code equals 1000 and op ID does not equal previous op ID, B1 G code equals 1002. So first we grab the actual value, then we do some checking and maybe some manipulation. So all three of these lines right here have to do with setting the value of B1 G code, right? So these three lines here, this line, and this line, all only have to do with setting this one variable. Now we set the next variable in our list. So we've got our first variable set. Now we're setting our second variable. B1 T code equals $T$. We're capturing the value of the tool number. Now we capture the min and max XYZ extents. And it's as simple as using the predefined variables Xmax, Xmin, Ymax, Ymin, Zmax, Zmin with a $. So we set our buffer variables equal to these variables. And then B1 G code equals write buffer, so wbuff, buffer number 1, and we're going to use the write counter variable. So WC1 says start at a number, and every time this gets called, every time wbuff gets called, this value gets automatically incremented. So when we started out with our buffer definition, WC1 started at 1, RC1 started at 2. And you notice it says, yes, 2 is correct for this case. So WC1 is going to start at 1. That means the first time that we call this, we write to the first record. As soon as we get done processing this line of code, WC1 gets incremented by 1. So the next time we loop through and this gets called again on the next tool, it's now equal to 2. So we set all of our variable values, and then we write to the buffer, and this thing gets incremented again. And that is the process that happens for the read and write counters. And one of the other things that's confusing about buffers is that every time wbuff or rbuff gets called, this value gets incremented, unless you turn off that behavior with a special variable. So we got P write buff 1, and then P write buff 2. So
basically,
go ahead.
So basically, that generates the min, max, Z information on the setup sheet. Then, is that what that's?
Yes, and that's now. This is mil.set. I don't know what oh wait, no, I want to do that and then I'll save that. Okay, good. This is mil.set, and this only does, oh, here we go. So you can have different settings for the XYZ limits. Output min max XYZ information. 0 is no, 1 is info only for each tool, not for the program. 2 is only for the entire program, and 3 is for each tool and the entire program, if you have more than one tool. So we have different options of, which ones we output. And you can also, notice it says individual axis output options if XYZ limits greater than 0. So you can turn off X and Y, for example, if you wanted. Say you only wanted your Z limits. You could do that as well. Now, one of the things that we can do go. One of the things that we can do here is just turn on these keep flags. And if we now run that, let me see where it's posting to. So it's posting to my MKMX7 mil NC, and if we go look there, It might be in the NCI
It was the
file.
.doc
There it
file.
is. What's that?
I think it was the .doc file. Go back. Yeah.
Well,
Top
that's
table.
yeah, that's the setup sheet itself,
Okay.
being output. What we're looking for, if I go look in mill NCI, you see this
Oh,
T.tx2?
yeah.
TX2 is going to be the name of buffer number 2.
Okay, yeah, okay.
So this is
Yeah.
this is a different one that I was working on. That's not actually the one that we want. So what we need to do probably is name those buffer files. So let me go back here, mill.set. I'm going to look for fbuff. And what we do is before the buffer declaration, it has to be done before there, we're going to set S, BUF, and then I'm going to do control spacebar. And you can see that we got S buff name 1, S buff name 10, S buff name 2, 3, 4, 5, all the way through 9. So these are the 10 different buffer names. So I'm going to set S buff name 1, and we're going to set that equal to someplace easy to find. So I've got like a C temp file, and then we're just going to call this mill set. How about buffer 1 dot tx1. Now,
Okay, yeah.
tx1, tx2, tx3, those are the default file extensions all the way through tx0. So tx0 is buffer 10. Those are the default names. You can make it .doc. You can make it .txt. You can make it whatever you want, but just to help keep it easy to distinguish, I'm going to set this one here. So the buffer number 1 .tx1. I'm going to copy that line. I'm going to search for fbuff again, and here's buffer number 2. So I'll put this right above there, and we'll make this buff name 2. And we're going to say that this is buffer number 2, and it's going to output as tx2. So we've set the keep flag, but we also have to tell it where we want to save it. There is a default location. I would have to look up and see where that default location is. I don't know if it's program files or wherever the post lives. It might be where the post lives, actually. So we might go looking for those in mill posts folder and find them there. But regardless, now we know where we want them to go. Oh, what do we got? What do we got for our error message? I wonder if it won't let me have a space in the name. And let's see what we've got for...
I used to check those errors.
Yeah, I might need a backslash in there too. I'm looking at C temp. So if I go C colon backslash temp, I think I've got a misspelling. C colon backslash temp mill. Let's just go underscore set underscore buffer2.text. And I bet you it's just the colon or the backslash missing right here that's screwing it up. So
Yeah.
I don't think the space matters all that much, but as a convention, as a preference, I prefer not to use spaces. I prefer to use an underscore or a dash if possible, just because as a programmer, you know, it's one of those things where those are always hard to spot. Do I have one? Do I have two? You know, that kind of thing. So let's close Simco so we get fresh output and run setup sheet again. All right, so we get our setup sheet doc, no errors. And if we go look in ctemp, here's our buffers. So if I look at this buffer, this is what we just buffered out. start of file tool change, actual tool change, actual tool change, actual tool change, end of file. Tool number, right?
Yeah.
Min, max, XYZ extents.
Yeah.
Okay? It does not write min, max, XYZ for vector toolpaths. Okay? So a 5-axis toolpath itself only outputs vector position information. So you have to have all your logic to be able to resolve in terms of the machine where that position is. As far as I'm aware, there's no logic that I've got access to that would let you calculate 5-axis XYZ extents from a 5-axis toolpath. Now, if you're running this on a table machine that actually, where you're doing mostly 3+2 positioning, you're just using tool planes, that will write to the X-min, X-max variables, all of the min-max variables. So then you could get access. Okay, so that was buffer 1, right? Buffer 2 captures the tool changes, and then it captures the cutter comp state. So if we look back here at buffer 2, this is for cutter diameter compensation setting storage. So read and write pointers, size 2 to hold the size of buffer 2, and we're storing 4 variables. We're storing the G code value, we're storing the CC comp value, we're storing the value of CC $, and we're storing the value of CC computer. So if you look down here at P write buff 2, Mastercam actually has several different predefined variables that hold different bits of cutter comp information at different times during the processing of the NCI. So the first thing we capture here, again, we've got those 3 lines that set B2 G code. So all we're setting here with these 3 lines of code is the value of B2 G code. Then we set B2 underscore CC comp equal to CC comp, or C comp, right? Cutter comp. So we have a variable that holds that. Then we have one for CC $. So you notice B2 underscore CC equals CC $. Then we've got B2 CC underscore computer. Looks like we got, here's Craig. Hey, Craig. Go ahead and unmute you there if you got a...
Hey, how's it going?
Good, Craig. Good. Yeah, actually, we're just about to wrap up for the evening. You just caught us right here at the end. We've got some different times for the office hours this time. So each day, Tuesday, Wednesday, and Thursday, has a slightly different time. And I'm doing that to try and give everybody kind of on the East Coast and the West Coast one of the days that works for them. So like today we were doing 7:30 to 8:30. If we look at Wednesday tomorrow, we're doing, I think, 8:30 to 9:30. Or let me check that real quick. Okay. Yeah, these are Pacific times. So today was at 7:30. Tomorrow's at 8:30, and then Thursday night's at 9. and then we repeat.
Okay.
Then we repeat that. Oh, this one's messed up. I gotta fix this one. But yeah, this should be 4:30 Pacific, so it'll be 7:30 Eastern. Let me actually just go edit the date and time. It's Eastern time, not Pacific. Okay, so yeah, so 7:30, 8:30, and 9 on Tuesday, Wednesday, Thursday, Tuesday, Wednesday, Thursday.
Okay.
Yeah, so no worries. I'll get this one processed though and get it right up there. Basically, we've been going through the .set file and looking at the default buffers that are in the .set file and kind of discussing what those do. And then I think DJ's got some questions about how to add more stuff to the .set files to output a good setup sheet. So that's what we're going to be be taking a look at, how to take some of this data that you want and dump it out to a file, and then maybe bring it into something where you can do more manipulation like Excel, so you can use VBA and have access to a lot of programming tools with lots of help and documentation and all that stuff. So we're just about coming to the end of class tonight. How are you feeling, DJ, about going over these two buffers and seeing what we're doing with them?
Did you say another night?
What's that?
What did you say again?
Oh, DJ, I was saying, how do you feel about what we've covered so far with looking at these two buffers? Are you starting to understand what we're doing as far as reading and writing data to and from the buffer?
Yeah. Yes. What I've done to pare down the information, like I say, that it puts out by default, I've just put I've commented out some of the features in here. I can't say exactly what, but
Sure.
When I use it, I just get like 4 lines of information, and one of the ones that I do like is the min max for the Z.
Mm-hmm.
So the operator or I know where the Z starts from and where it ends at. Because a lot of times you need to know the depth of cut, the ultimate depth of cut for
Sure.
how long to stick a tool out or how much flute length to have. It looks like that has been explained a little bit better to me, so maybe I can manipulate it with the buffers then, instead of what I've done in the past.
Sure. Yeah, turn on and off some switches and
and
do some more manipulation. Well,
yeah.
So what I'd recommend is start with a fresh set file and set some of the switches up at the top. See what you're getting for output.
Yeah.
And then create a zip-to-go file from within Mastercam with your files and email it to me, and then we can take your file and we can go through and do some more editing, and we'll do it the right way. And then if there's things that you want to add, we can add it as well, and do some customization there.
Okay.
Cool. Okay. So do that. Maybe we can tackle that issue Thursday.
Okay.
DJ or Craig, if you're available tomorrow, I'd like to get started on the Maxim.
Great.
Does that sound like a good
Sounds
plan?
good.
For you? Okay. Okay. Cool. So yeah,
I guess I'm batting 1,000 on getting these classes on time.
No worries, man. No worries. I felt bad about getting the notice out so late for Saturday, so I'm trying to stay on top of it and make sure everybody knows when it is, and give you guys the help that it's hard to find.
Yes.
So, and if you've got an example, Craig, that you want to work through on Moxim, some sample files set up, that would help me out too. So if you can send me anything on that, we can start taking a look at your file and just modify, make the mods to whatever you want to do.
Okay.
Does that
Sounds
work
good.
for
I'll
you?
see if I can gather up something. I really kind of got a blank page on. I was going to take an existing machine, but
that's fine.
Try to modify the generic.
No, that's fine. I've got a generic example we can use. I didn't know if you had something you were struggling with or you were starting from ground zero. Starting from ground zero is okay. We'll start out with a simple example start from the ground up, because some of that's going to be new to me too. You know, doing the buffer files, I've been doing buffer files for a while, but doing it to get specific output to drive MockSim, we're going to have to look at what we need for formatting and come up with a way to structure the output. It shouldn't be too hard, you know, but
last time we talked about it, apparently they didn't give you too much information to get started either.
No, it's kind of a shot in the dark. You know, you can go and get training from some of these guys, but it's definitely so. Part of the reason that they don't release the information is because they don't want the tech support burden. So even though they've added this function or this feature to their software that's created by a third party, they don't want to actually, you know, invest the support energy into teaching people how to use it, partly because they know so little about it themselves because it's from ModuleWorks.
Yeah.
So I think that's what it is. I mean, I would love to go and actually get some training from ModuleWorks on some of this stuff, because I feel like, you know, like I'm a decent post writer, but I don't know it all. And, you know, learning about some of that stuff would be awesome. You know, I'm pretty sure I've got an idea of how to make this work for us. So we'll battle through it and get it to work.
Okay.
Yeah. So, okay, guys. All right. Well, it's 8:30. I think we're gonna wrap it up for tonight and pick it up tomorrow, and we'll start with some buffers for machine simulation.
All right. Sounds good.
All right. Thanks, guys.
Thank.
Yep.
Okay, Colin, thanks.
All right. See you guys tomorrow.
Alrighty.
All right.
Okay. Bye-bye.
Bye.
Bye.